Let's begin. The first problem set is due today. You can hand it in at the beginning of class or at the end of class. That's your choice. There are two separate piles. We all understand this? Okay? A couple of announcements. First of all, on Tuesday, your final seat will be assigned. So first come, first serve. Once you arrive here, get in your seat, and that'll be your seat for the balance of the semester, assuming you're enrolled in the course. And in that respect, a number of people that are waitlisted have asked about whether or not they're going to get into the course. It depends on whether people who are currently have a property right to being in the course give it up. There's a wait list, and the wait list is handled by undergraduate advisors. They give a preference to those who are majoring. If you're on the EAP side, if you're majoring in EAP, you get a preference, and you'll get bumped up in terms of the queue on the wait list, and likewise in economics. If not, you're in the queue. And it's going to depend upon whether people drop the course. And I'm hoping when it's all said and done, and we get to Tuesday or shortly thereafter, the people that are left in the course, that are taking the course for credit, are those in the first type we discussed in the first lecture, namely those who are prepared to meet the challenge, to treat the course in a serious way, but more importantly, to be driven by merit. And if you're not prepared to accept those conditions and you're in the course, it may be in your best interest to drop and let somebody on the wait list step forward. Okay? All right. Any questions about any of what I've just described or anything that we've discussed up through the first three lectures? So when I ask if there are any questions and there are no questions, I have no other alternative but to assume you understand everything we've covered. We all must be doing a very great job, if that's true. Okay, well today we're going to take where we left off in the last lecture. Recall, we said the analysis using supply and demand is to begin with some event or some major change, go through three steps. One, does that event or major change result in a shift in the demand function, a shift in the supply function? The second step is to look in which direction that takes place. Then the third step is to evaluate the new equilibrium versus the initial equilibrium, where the initial equilibrium is the equilibrium before the major change or the event has taken place. Today, we're going to put real content on that, and we're going to do so by introducing the notion of elasticity. And we're going to completely describe the different measures of elasticity and what they imply about responsiveness. And if we're looking at demand equation, we're analyzing what the responsiveness of buyers are to some change. And if we're looking at the supply side, we're looking at the responsiveness of sellers to some change. All right? Okay, so what are the questions we're going to focus on today? What is elasticity? What issues arise in the implementation or the use of elasticities? What is the price elasticity of demand? How is it related to the demand curve? And equally important, how it's related to revenues or expenditures. What is the price elasticity of supply? How is it related to the supply curve? And what are income and cross-price elasticities, and how can we use those measures to improve our understanding of the analysis that we talked about in the last lecture and put some quantitative implications about what the effect of some event change is. Okay, let's look at a concrete example. Let's suppose that you're a designer of websites. And you're sitting there, you have been charging your clients $200 for each website that you construct. And you're currently selling 12 websites per month. Okay, what is that? You're making $2,400 a month? You're barely surviving, right? In most parts, but at least in this part of the world. Your costs are rising, including your opportunity cost of time. And you're considering raising the price to $250. Is it in your best interest to do so? Right? So keep that example in mind, and we'll return to it. But what we want ultimately to do, we're looking at some event, right? And the event is that the seller of these websites is considering increasing the price that he or she is charging for the construction of those websites, right? Okay. Now, right out of the box, we know that the law of demand tells us that if we increase the price from $200 per website to $250, the amount of websites per month that we're going to sell, we would expect to fall. That's the law of demand, right? It's a downward sloping demand. As I increase my price, I should expect that I'm going to sell less websites, all right? And moreover, if I'm selling fewer websites, how is it going to affect my revenue? Is my revenue going to fall? Is it going to rise? Is it going to remain the same? Anybody know the answer straight away? I haven't given you enough information to give you an answer? Yes. I hope so, otherwise. You're quite right. It's going to depend on the elasticity. I've given you a number of hints. It clearly is going to depend on the elasticity. Right? And I'll give you the conclusion, and then as we go along, you'll see the basis and the foundation for why that's true. If it turns out the demand for this person's websites, if it's an inelastic demand, by increasing the price, their total revenues is going to rise. If it's elastic demand, the opposite is going to happen. And if it's unitary elasticity, his revenues aren't going to change. Her revenues aren't going to change. Okay? Let's see if we can give the foundation. But before doing so, let's look at elasticity measures and how we arithmetically measure elasticities. It measures, in this case, looking at the concrete example, how much demand for your websites will fall if you raise your price. It is a numerical measure that focuses on the responsiveness of Q subscript D, which is quantity demanded, or Q superscript S, which is the quantity supplied, and I'm going to be moving along a given curve, right? Because we're talking about, as we defined in the last lecture, and as your textbook goes to great pains to define, we're talking about quantity demanded or quantity supplied. So the curves, we're not talking about shifts in the curves, we're talking about a given curve. All right. Okay, first, the price elasticity of demand measures how responsive demand, the quantity demanded, is to a change in price. And quite simply, it's nothing more than the percentage change in QD relative to the percentage change in price. Intuitively, it's nothing more than the price sensitivity of buyer's demand. So if I've got a group of buyers that are terribly loyal and they don't care what the price is, they're not sensitive to changes in prices, right? Okay, so that's our measure. going through a concrete example, suppose the price rises by 10%. Graphically, we're looking at an absolute price move from P1 to P2 and a quantity decline from Q1 to Q2. Now, since this is a downward sloping demand and the relationship between price and quantity is a negative relationship, the elasticity is going to be a negative number. All right? But as your book points out and in lecture as we move forward, we are going to, whenever I tell you it's a demand elasticity, I'm not going to say it's a negative 6.4. I'm going to say it's 6.4. And you know it's got to have a negative number in it if it's a demand elasticity. Okay? All right, so this demand elasticity turns out to be 1.5, just applying that simple formula, the percentage change in quantity demanded relative to the percentage change in price. Okay, noting that as I've already pointed out, price and quantity move in different directions. That makes the elasticity negative, but we will be referring to this throughout the course as positive numbers. And once you know it's a demand relationship, you'll know it's negative. And by the way, that'll be clear in our communication. On an exam, however, don't lose sight that it's a negative number. Because if you go through the computations and you carry through the computations as though it's positive, you'll get the wrong answer, right? Okay. Yes, there was there. Say what? What do you mean the answer is never negative? No, when we communicate with one another, and if I tell you it's a demand curve, you'll know that the elasticity is actually negative, but we'll communicate giving the absolute number. Okay? But all I'm saying, I'm warning you that on an exam or in a problem set that you're working on, you have to pay attention to the sign on the elasticity. Okay? All right. Okay, now, it turns out that this is not discussed in your book, but up to this point, I'm talking about arc elasticities, not point elasticities. What's the distinction? I'm looking at discrete moves in prices and quantities, and I'm measuring the elasticity from one discrete point in the two-dimensional graph to another. If I get a point elasticity, what is the elasticity at a particular point on this demand curve, say right here, then I can compute that point elasticity by, you'll see in a moment, by just taking the slope times the ratio of price to quantity. But that requires the application of calculus, and that is not expected of you in this course. So all of our elasticity measures will be arc elasticities, namely, we'll be measuring the elasticity from one point on the curve to some other point on the curve. And when we do so, a problem arises. Because if we're looking at the distance from A to B and measuring elasticities moving from A to B, we'll get a different answer than if we measure the elasticity from B to A. Let's see where this to show in this particular example. Going from A to B, the percentage change in price is 25%. And I've shown you the actual calculations, taking this point on the vertical price axis, 250 less 200, divided by the price at point A, I get 25%. Okay? And then I want to move forward to compute the elasticity, so I have to compute the percentage change in quantity as well, right? Okay, just a minute. And if I do that, I'm going to compute the percentage change, again moving from A to B. I'm going to be taking 12 minus 8 divided by 12. And when I go through this analysis, I'm going to get, for the price rise, if I go from A to B, the price falls by 25%, but price rises by 25%, but the quantity falls by 33%. And I end up with an elasticity of 1.33. In contrast, if I measure the elasticity from B to A, I'll get a 20% fall in the price and a 50% rise in quantity. And as a result, now my elasticity is 2.5. So how do we resolve this dilemma? Always measure the elasticities in one direction? That's not very satisfying, because if somebody comes along and says, okay, I'll compute the elasticity for you, but they compute the elasticity beginning with point A, moving to point B, and somebody else comes along and computes the elasticity beginning at point B, going to point A, they're going to get different answers, right? So what's the resolution? Any volunteers? Yes. Yes, the midpoint method. And that's exactly what your textbook talks about. If you employ the midpoint method, namely take the midpoint between A and B, and use that in your denominator, you'll get the same answer for both cases, whether you're moving from A to B or B to A. And here it is. The in value, whether it be A or B, the start value, and it's got to be the other discrete point on the curve, divided by the midpoint. And that midpoint is halfway between the start and the in values. And it doesn't matter which value you start with if you employ this simple methodology. Yeah, sure. Okay? You'll get the same answer regardless, and that's what I'm going to show in the next slide. Okay, the midpoint for the price move from 200 to 250, or from 250 to 200, that midpoint is 225. So I get a percentage change in price of 22.2, and if I look now at the quantity percentage change, I end up with 12 minus 8, and my midpoint with regard to that move, that delta, that change, is 10, and the percentage quantity change is 40%, and the price elasticity of demand is 1.8. So if you reverse it and move from these 250 to 200 rather than 200 to 250 on the price, you'll get the same answer. Okay? Let's look at another arithmetic example. This is a fellow that's sound asleep in his hotel room, and what we're asked to do is compute the price elasticity of demand for hotel rooms. Now, there's a hotel proprietor that's trying to decide whether they're going to increase the price, the fees for overnight lodging in this particular hotel. And let's suppose that initially the price is $70 and the number of clients at the hotel is 5,000. Let's suppose now the price at 90, a $20 increase, that the quantity demanded falls to 3,000. And the question is, under those circumstances, what is the elasticity of demand? Now, many of you should be able to compute that straight away, given what I've just walked you through in terms of the percentage changes. You have to take the percentage change with regard to the price move, take the percentage change, take them both, the delta relative to the midpoint, and do the computation. Has anybody done that? Yes? It is the percentage change in quantity over the percentage change in price. You don't think it's 2, it is 2. It is 2. And here's the actual calculation. The midpoint turns out to be 4,000 in terms of the quantity delta, and the midpoint on the price delta is 80, and we get 25% there. We take the 50% divided by the 25%, and we've got an elasticity of 2. Okay? Right? Yes?
What does it mean, elasticity?
What it means is that the curve, or the responsiveness, and the price sensitivity of the people who are demanding this particular service, the lodging that's available to them, they're very sensitive to price changes.
Is the high elasticity more sensitive?
Yes, yes, we'll see that in a moment. Right. Okay. What determines the price elasticity? Now I'm going to give you a number of examples, but let me set the stage for the examples that I'm going to give you to see if we can intuitively work through the logic of how elasticity will change as we look at different types of goods. Right? And in each example I'm going to give you, let's suppose that both goods change by 20%. That is to say, their prices change by 20%. Okay? Now, for which of these two goods, and we're going to compare two goods in all of these examples, right? And we're going to have the same price change, and what we want to do is look at the result of what is the quantity change, right? And I want to know why you would expect the quantity change for a common percentage change in prices. And then we want to use these examples to infer general rules about what we would expect with regard to the price elasticity of demand. And that comes back to the question you just posed about what does 2 mean. I think we'll be able to put more content on what that actually means. Okay, let's take the first example. Breakfast cereal versus sunscreen. Okay? We're presuming that the price of sunscreen and the price of breakfast cereals both change by 20%. What's going to be the effect on quantity? Each of their respective quantities, right? What's going to be the effect on the quantity of breakfast cereal sold? What's going to be the effect on the quantity of sunscreen sold? Think about it for a moment. Whoa. Did you not get on my end? I'm sorry, I'm teasing. No, I think that's it. Okay, so you've had a chance to think about it. Do we have an answer? Oh my God. Any volunteers? Yes. Why? I see. Does everybody agree with that? Do you agree with that? So so you've said just the opposite of what he said. You're saying the quantity change of breakfast cereal is going to be much larger than the quantity change for sunscreen, given that both of their prices increased by 20%, right? How many people agree with her? Good, because that's the right answer. Okay, breakfast cereal has a number of close substitutes, right? You know, I can, instead of eating breakfast cereal, I can eat waffles, whatever's left over from the night before, eggs, pancakes, whatever. I can easily switch to those if breakfast cereal becomes dearer, in the sense that its prices increase by 20%. In contrast, sun cream has no close substitutes. So if you've got light sensitive skin and you spend any time outdoors, you need, or most people would recommend that you use sunscreen, right? And what are the substitutes for sunscreen? Staying inside, I suppose. Pardon? Was it umbrella? Fair enough. Fair enough. But even so, there's no readily available substitutes. That's the point, right? Okay, so the price elasticity is higher when close substitutes are available. That's the lesson from this particular example. Okay, let's turn to a second example. Blue jeans versus clothing. We've all bought blue jeans and we've all bought clothing at one time or another. So once again, for which of these two goods, if there's a 20% price increase, which one is going to have the largest impact on the quantity demanded? Yes? Does anybody have an opposite inference or an opposite conclusion, or do we all agree with that basic observation? And what about clothing? What about clothing is just going to be a smaller percentage change in quantity as a result of that? You use the phrase, it's a narrower good. I presume you mean by that, blue jeans are narrower than clothing. Right. Right. Would drop what? Drop more, did you say? No, you didn't say that, did you? You didn't say that. Did you say that? You did? The quantity would drop more for clothing than it would for blue jeans? Okay, it would drop more for jeans. Okay, good, good. All right, she's dead right. All right, this is generally true for narrowly defined goods. They have many more substitutes. Khakis, as she noted. Speedos is another. There are a few substitutes available for a broadly defined good. There are too many substitutes. Too many substitutes for clothing other than living in a nudist colony. And as a result, the lesson is that price elasticity is higher for narrowly defined goods than broadly defined goods. Okay, let's go to a third example. Insulin versus Caribbean cruises. I'm sorry. Certainly. All right, may I go forward now? Hey, by the way, when you ask me to go back, that's fine. But as soon as you're through, let me know so I can go forward. Because my natural inclination will go back and then move straight away. All right? Okay. Insulin versus Caribbean cruises. This is fairly straightforward, right? So what's going to be the quantity of impact when there's a 20% increase in both of these two types of goods? Yes? Everybody agree? Anybody has a different